Welcome to General Structure 2 Lateral Forces, Lesson 4 quiz, question number 6. It says that a building in which core walls provide the only significant lateral force resisting elements may be inadequate to resist what? A. Bending, B. Torsion, C. Vertical acceleration, or D. Diaphragm stresses. That's A, B, C, or D. Let's go ahead and cross out as we see fit. And this one, I'm not a huge fan of this question. I don't think it's all horribly clear. But if you'll go to page 101/2 at the end of 101 and 102, it says torsional effects are most significant in unsymmetrical buildings. These include buildings with an L configuration and whose structures whose shear resisting elements are in a core far from the building's perimeter. So, it says a building in which core walls provide the only significant lateral force resisting elements may be inadequate to resist what? I'm guessing it's torsion is what they're trying to get at. So, I always heard they don't quote me on this, but I always heard that the Twin Towers had a strong core. Now, obviously, this is oversimplifying, and it had the outside were kind of thin, but then in the core, they had the elevators and everything around there. But that's where the main strength. Now, I may be 100% backwards and off on this, and the main strength came from the outside. I don't remember what it was, but the whole thought was, hey, this is open. They could keep it as open as possible because they had all the strength in here, and then they had the other strength out here, so they didn't have to have, you didn't have to have columns every so often. But the whole thought is, okay, torsion-wise, if this was even more unsymmetrical, you're looking, think about a moment going sideways, I guess, and it's going to put torsional effects into this building. So the more that rigidity and that strength, that resistance capacity is in the center or away from that. If you think about it, if this were the strength was out here, it's just like when you're looking at like an overturning moment, where if you have a building right here, the more you have this dimension right here, if you have a foot that's way out here, or if you have a building that is this long, you have that longer resisting leg, as I will call it. So that's kind of the same thing. You have, if this is the center of rigidity, if this was the more rigid members were out here, then you would have this dimension, this resistance leg, as compared to this resistance leg. So therefore, it's going to resist tension better the more you have away from that center of rigidity. I think that makes sense. I'm not going to beat that like a dead horse. So let's figure out what is the best answer. And the answer is B, torsion. Bending, you can make an argument to say, well, if all of your resisting elements are really, really small in the core, that's going to have less. I mean, if you look at it where this is the bending right there, and this is your neutral axis, and if this is smaller, well, you're going to have less bending capacity, and that is also correct, because if you had the same system where this is your majority of your steel or whatever was out here, your structural elements, then you would have a larger, it's just if you look at, like, if you took an I-beam, that's why an I-beam is good, because neutral axis, you have more area away from the neutral axis. It's the same thought process, and you could make a point for A, but I think what they're going for is B, torsion. Vertical acceleration, I don't think that would matter at all. If it's perfectly vertical, it shouldn't matter one bit. Alright, then D is diaphragm stresses, and I do not believe that's correct. Your best answer is going to be B, torsion. Alright, I will see you on question number 7.